All right, we'll start. This hopefully won't take the whole class. Okay, so I guess maybe to start off, you might be wondering about the exam, so we can talk about that first. So the exam will be mostly multiple choice. There will be a few short answer. It will be comprehensive, obviously, because there was no midterm for the course. You'll bring a pencil. You can do the short answer and the multiple choice both in pencil. It's essential that you do it for the multiple choice because if you want to change something, you'll have a form. You'll actually fill it out on a form, and the scanner also won't read pen. So bring a pencil. I'll have extras in case you forget. Not a big deal. But the short answer you can also do in pencil. It's fine, and then you can erase it. You can bring one piece of paper, front and back, 8.5 by 11, just a normal piece of paper, and you can put whatever you want on that piece of paper. So if you want to memorize something, you don't have to. You can just write it down and bring it. So none of the questions will be straight memorization questions. They're all going to be conceptual questions. I'm trying to test whether you understood the course material. I'll try and ask you maybe about new scenarios where something from the course applies, or looking at something we talked about from a different perspective, like those types of questions. So yeah, that's all I have. Is there questions about it? Oh, and it's across 2 rooms. So what I'll do is I'll just randomly assign you to one of the 2 rooms, and I'll send it to you by email. Maybe a day before, whenever I get around to it, I'll assign you to one of the 2 rooms. It's the exams in Faubourg, which is across from the EV building, and yeah. Any questions about it?
Any sample question, like previous?
So I used to have sample exams. I don't know if maybe when I switched to Moodle they disappeared, but they were kind of useless anyway because they were so old and the course itself had changed so much since then. And so there was only a few. If you go digging around on my website, you can find old versions of the course. You can probably find you can probably find the questions themselves. But like I say, they aren't particularly useful. But yeah.
So there will be questions with short answers are expected, but will there be any question where lengthy answer is expected?
Where?
For the exam, you said that there will be multiple choice
Yeah.
questions and some questions short answers.
Yeah.
But is there will there be any question with a long answer, lengthy answer?
Depends on your definition of lengthy. So when I say short answer, it might have 3 or 4 points that you have to hit. So it would be like a question that might be out of 4 marks. So there's 4 kind of ideas that you would have to say, kind of thing. So that would be typical, or it might be out of 2 or something like that. So it's not like it wouldn't be like writing a full page, like from top to bottom. But yeah, usually it'd be explaining something or or analyzing something and saying what's happening, giving a reason for it, that type of thing. Yeah.
Two recommended readings like large ebooks,
Yeah.
threat modeling, and other is social engineering.
Yeah.
Do you expect us to go through it from exam perspective?
Sure. Yeah, so the exam will be solely based on the lecture notes. Sorry, let me correct myself. It'll be solely based on the lectures. So especially, sometimes I say things and maybe it's not in the slide, or maybe when I was writing, I might not have written it down explicitly. And so that's still eligible. If I said it in the class, then it's on the exam. But if I didn't say it in class, we didn't talk about it, it's in a textbook or something like that. Those are they're there to help, but you don't have to read them at all. No, so I tried that the first year and it was kind of a disaster. Students didn't like it. I don't know. It's it doesn't change anything. But anyways, yeah. So no negative marking. So multiple choice would be there might be 4 to 6 answers. So you have a 1 in 4 or 1 in 6 shot at getting it right, even if you don't know anything. And and no negative marking. Yeah, so the slot is 3 hours. I try not to make them in some courses, the length is a challenge. That's part of the challenge of the exam. mine, I don't try and make time the challenge. So usually like the first student might leave within an hour, a little less, maybe 45 minutes. And then, but then there's a lot that maybe stay till the very end because they, I don't know, they just keep going over the same things type of thing. But I would say that like, it's hard for me, I can say, oh, I did it in half an hour, but like, obviously I know what I'm doing, right? It means nothing. But I would say that like, it's kind of like maybe a midterm length, like something that is meant to be an hour and a half or something like that. But you have the 3 hours if it's there if you want to use it. But yeah, it's not going to be, don't expect something that's super long. Yeah, so it might be like let's say 3, 4 short answers and 30 multiple choice, something like that. Maybe some of those are true, false too. But yeah, yeah.
Do we have any true or false type questions? True or false type?
Yeah, so that's under multiple choice. Yeah, so there'll be maybe a few of them will just be true, false, and then some of them will be multiple choice.
They
And
are also
some.
scenario based, right? Like you give a situation and you ask is it true or false?
Yeah, it could be that. Yeah, or it could be like just.
Basically, any direct topic like is this true or false? Like from the red to notes.
Yeah, it could be testing your knowledge of something. Yeah.
Sorry, if from multiple choice question, more than one option is correct, you're gonna mention it. For example, choose 2 or 3 of.
Yeah, so that's a good question. So my advice is, first off, I'll always write it with one answer in mind. And usually I'll say like choose the best answer. So sometimes like maybe for some technical reason you might be able to argue that one of them, but at least one will be like the best answer for them. So I'll try and remember to write like circle the best, but that's my intention is that you're going to circle the best. But some of them might be like A and B are true, or you know, like A and D are true or something like that might be one of the options, you know.
And you mentioned in the question.
Yeah,
that
exactly.
maybe it's 2.
Exactly. So in that case, that question, like say, you know, there was a question, there was option A, option B, option C, option D, and then the fifth option was A and D are both correct. Then you would circle that one, right? As opposed to circling A and circling D. So I'll tell you that the Scantron forms that we use, if you do more than one answer per question, you just automatically get 0. So yeah, so you will always explicitly be picking one answer, but some of the answers might refer to the fact that 2 of them are true.
If there should be 2 answers, you're gonna mention you should choose 2.
Yeah. So okay. You'll never have to choose 2.
Okay.
Okay. Maybe I'm not being clear. You'll always have to choose one.
Okay.
Yes, but the one that you choose, like the answer itself, might say something like both A and B are true.
Okay.
Does that make sense?
I got it.
Yeah. Sorry. Yeah. Okay. Anyways, yeah. You just choose one. It'll be obvious. Yeah. And don't even if you want to, don't choose 2. So every year there's like one student that didn't read it closely and ends up choosing 2, and then they get 0 on all of those, and it turns into a mess. But, yeah. Yeah, so I think that's it. Cheat sheet, pencil. Yeah, just choose one. It'll be split across 2 rooms, so I'll be wandering back and forth between the 2 rooms. And yeah. So cheat sheet meaning just, you can bring one piece of paper with whatever you want on it. So whatever you'd be going to the bathroom and checking on your phone, just write it on your piece of paper so you don't have to do that.
But it means that there is no useful information on that cheat sheet.
Yeah, so actually my goal is that when you create the cheat sheet, first off, it will help you learn the course.
Memorize it.
And then secondly, you'll actually never have to look at it in the exam. So those are my 2 goals. But yeah. Okay, other questions? Yeah.
For some lectures, you have provided as many practical examples like the lecture 10 for the airports. I'm curious that is there any really technical or high-level concepts or some technical issue you expect us to learn from this example?
So my main thing would be with all those examples is just that you understand the example. So I might, if you understand it, you would be able to, like, for example, see a new scenario where it's the same principle or whatever. So I'm not going to ask anything that's not in the lecture. So if in the lecture I'm not like, this is the underlying principle, then I'm not going to, in the exam, ask you like, I won't ask you things that aren't in the lecture itself. So if the lectures themselves are just examples, like some of them, like the social engineering and things like that, then yeah, like I might say like, if you did this instead, would it fix the problem? That would be like a good example of the type of question I would ask, right? Or vice versa, like it works this way, what if it worked this way instead? Would that introduce a problem? That type of thing, yeah. And then there's no way to study for that question because you won't see it until the exam. The only way is to be very comfortable with what is, like what I'm relating it to in class, yeah? So that's what I recommend. When you study, just go through and just make sure you understand, like ask yourself, did I understand that? Sometimes like there's scenarios where, you know, there's a bunch of stuff happening, going back and forth, and you sort of, like you know what it is, but you don't know why. Like that's where you spend the time, is like to bring yourself to actually understanding like what it is, yeah. So if you understand all the concepts and all the examples, you'll do well.
There was this lecture ethics. It was online, so they were just two YouTube videos and
Yeah.
some additional material. So is it enough or just?
Yeah, so I have one slide at the end of this lecture where I'll talk a bit about it. So those are two videos. Some of you have watched them already, but you can watch them because next Tuesday is technically a class. So we won't meet in class, but you can watch them instead. And I'll ask you some high-level questions about them on the exam, but I'm not going to go into detail because we didn't cover it in class, right? So something that I could reasonably expect that if you just watched it, you didn't have a chance to, talk about it, that you would get from it. So they'll be very high level for those two, but it will be covered. There will be at least a few questions on that, and but yeah, not like super in depth. Okay, yeah. So just to show you what we're talking about, so we're here. So today's lecture will be on the same origin policy, and then next class, which is Tuesday because of Good Friday, it was a holiday. So if you have other Friday classes, like if you have a class earlier, you'll also have that class on Tuesday. So every Friday is also next Tuesday. But anyways, it's confusing enough, so we just won't have a class, okay? But you can watch these two videos. Okay, other questions? Okay, one other thing, course evaluations are due, so I encourage you to do it. You can practice your Lacquard scale, like filling things out. They're kind of weird, so like 1 is a good number and 5 is bad. So every year there's like 5, 5, 5, 5, 5. And so I don't know if that's like people think I'm horrible and the course is horrible, or if they just did it quickly without looking. So I want to warn you that, you're free to do 5, 5, 5, 5 if you believe it. But if you're intending to do 1, 1, 1, 1 and accidentally did 5, 5, 5, 5, then it does actually weigh the average down when you only have maybe 30 students out of a class that actually fill them out. Also, I do take feedback. So like, for example, I never recorded the lectures when I started, but then students would miss a class. They would say it on the course evaluation, so now I record them. And so like a lot of the different things that I've done is a direct result of comments that are left. So it's not just, I see it, it's anonymous. So if you say something, I don't know who said it. But I do read them and I consider what's being said, and I try to accommodate them. If it's a reasonable request, I'll definitely do it. So like one thing we did in this class was we switched halfway from notes. I've always taught with just handwritten notes. So you're the very first where I did slides. So like, I don't know if that's good or bad. Actually, since you did half and half, let's just take a straw poll. So tell me whether you like the notes better or if you like the slides better, or you don't care. So notes better? Slides better? Okay, show of hands. So that's almost everyone. Okay. And then don't care.
It's not a don't care, but it depends on what topic.
Yeah, sure.
Depends on what topics. For some topics, notes really help.
Right.
And for some, like
Yeah. So anyways, yeah, it also makes the lectures go by a little faster, but I try and slow down to compensate for it. But I used to do it originally just to slow myself down, because I could blow through 3 lectures in one lecture, you know, or whatever. And so it was mainly for that reason. But yeah, anyways.
Another question.
Mm-hmm.
Do you curve the grades?
Okay, yeah, so this is what happens. So I'll calculate your mark according to the course outline. So there is a marking guide in the course outline, and you'll never get a lower grade than what the course outline tells you. So I will, or I shouldn't say that, like, maybe I guess it's theoretically possible, but I've never done it in however long I've been here, 10 years of teaching. I've never curved down. So so if there's some curving that happens, it will only be in your benefit. It won't be to your detriment. There is no standard relationship between, you know, where does an A start, where does an A minus start, where does an A plus start. There is some standard things, but grad school is different because we don't have C's. Well, a C is a fail. So like normally you would have, like an F would be fail, you would have D's, like D minus D, D plus, C minus C, C plus, and then B's. But in grad school, you just, if you have a B minus, that's a kind of soft fail. You pass the course, but if you have too many B minuses, then you start failing the entire program. And then a C is an actual fail. So as a result, like I'll stretch the B's way down, right? So like someone that might get a D, what would be considered a D in undergrad, they still pass the course. You're going to get a B in this course because that's the lowest grade without a consequence, kind of thing, right? There is a lot of curving that happens, but generally, like say your net mark came out to a 95, you're getting an A plus period. Like there's no way you're going to end up with an A or an A minus, like with that kind of percentage. And if you have above 80%, you're going to have some flavor of an A, like an A minus, an A, or an A plus. You're not going to get a B with an 80% type of thing. Yeah. Now, maybe like if everyone got 100% on the exam, then it might be a problem. And so, but anyways, that's also something that's never happened. So, yeah. So based on my experience, so yes, there is curving. Historically, every time I've taught it, it only works in your favor. It's usually to boost the marks as opposed to drag them, or it's always 100% of the time. It's always been to boost the grades and not drag them down. And there's no rules about it either. And every year the cutoff is different. So it depends on the class and the marks and things like that. So but yeah. And then at the very end of the course, if you're curious, you can shoot me an email and say, give me the breakdown. And then I'll send you like, this is what I recorded. First off, it's a chance to check because sometimes, I don't know, maybe your assignment got marked, like put in wrong or something like that. And then you can see your number grade as well. And then if you really want to review your exam, you can also do that as well. So, but that requires an appointment because we don't hand back final exams. So you'd have to like email me and then I'll set up a special office hour in person or something like that. I can't do it over Zoom or anything. You have to come and you can look at the exam, but then not leave with it. And it's also kind of awkward with multiple choice because a machine marks it. I don't mark it anyway. So there's not really anything to review. But the short answer for sure, you can look at. And then another thing students are curious about is like, how long does it take to get your marks? So generally, I might have actually did something bad because I let you guys have your project way after the exam. And there's actually rules. It's something I probably shouldn't have done. So some of you are going to be graduating this term. And so you're supposed to actually get your mark back within, I think, 2 days. It might be 2 working days of the final exam or something like that. And then for everyone else, it's kind of like a 2-week kind of expect. So we mark them really fast for the people who are potential graduates. But I can't mark, if you're a potential graduate, I can't mark it until I get your project. So let me put it this way. If you're a potential graduate, you know it, and you want that mark really fast, then make sure to submit your project before the deadline and I'll mark it. But if it comes in the day of the deadline, then I'll mark it like within a day or two of that. But yeah. But yeah, it takes about 2 weeks or so. And then and it's not just in my control either. I submit it, then it's approved by the department, then the faculty approves it, then graduate studies approves it. And so it's there's a process to it as well. So it's not, those types of delays aren't always in the professor's control. All right, any other things you're curious about? Okay, good. All right, so let's, we'll just try and wrap the course up. Okay, so what we'll talk about today is kind of the flip side of the cookie policy. So we talked about cookie policy. This is another policy. It lives alongside the cookie policy. It was invented basically the year after cookies were invented. And it's a direct result of people wanting to weave together content on a website. Okay, so content, remember, is it's not cookies themselves. That's meta content. They're in the header files. But what we're talking about is when you download a website, you know, all the images, all of the audio files, the video files, those are all passive content. Style scripts, those types of things are what we consider active content. So I'll just show it to you. It's maybe easier. So I download this page. This is Moodle. It's got all sorts of crazy stuff happening. It's a complicated website. It's not a simple website. And so if I want to see, let me do a hard refresh just so that. If I remember how to do it on a Mac. Whatever. So for this website, I've sorted it by type. So you can see there's a bunch of style scripts that come down. There's some documents, so that would be like a PHP file. GIF would be a picture. Obviously, JPEGs are pictures. A bunch of scripts that come down, PNGs being pictures, SVG being a vector graphic. So that'd be like the favicon. And then there's, I don't know what Wolf2 is. Anyone know? Okay, and XHR, I know what it is, but I can't remember. Yeah, and anyways, whatever. So some crazy stuff that comes down. So these are all resources, okay? And the main question that we have is, these resources are coming from different places, right? So you can see the domain. So like some of them are coming from Moodle.Concordia, some are coming from YouTube, some of them are coming from Google. So they all have different origins, okay? So that's the idea of origins, okay? And the main question is, can these things all talk to each other? Especially if it's scripting. If it's scripting, it can program, right? So for example, the JavaScript that I downloaded from youtube.com called www.embedplayer, can that see the PHP file, right, that came from moodle.concordia.ca or not? Okay, so a browser needs to decide, basically how's it going to contain resources? Can everyone see everything else? Or do we want to protect some things from being able to see other things, okay? And so the policy that governs that is called the same origin policy. And you can get a sense of where we're going, which is if it's coming from the same origin, then it's going to be allowed to sort of interact with it. And if it's coming from a different origin, then it's not going to be, okay? But it turns out it's not quite that simple, okay? Or at least like what you think of an origin and also what you think of putting things together might not be exactly what you're thinking of. So that's why there's a whole lecture on it and not just like a one sentence explanation for it. Okay, so same origin policy governs how resources, so images, audio, all those things on a website are isolated from each other. What the browser is going to do is all of those things that you saw, it's going to tag each of them, So it's going to tag them with the origin. It's going to assign an origin to them. Okay. Now it won't necessarily be the source that it came from. We're going to see what an origin is. Okay. But anyways, for now it's going to try and tag them. And then what it does is it builds this big tree and it puts all the things in the tree. Okay. And the tree doesn't really matter. It's called the DOM tree. The point is that it's kind of structured. And the important point is that scripts can walk around on the tree. Okay. So if some image comes down, it gets put in the tree. And then you're running some script. What a script can do is it can walk over to that image. It can change it. It can replace it. It can read it. It can send it somewhere. It can do whatever it wants. Okay. So the website, your browser puts all of the resources together, right? Scripting's allowed to access that resource pool, okay? And then the question is, if you're weaving together content, do you have like 5 trees, like one for each origin, or do you just have one tree? You know, how is that going to work, okay? So that's the main thing. If you want to see the DOM tree, it's not even, it also would break HTML down into like the actual elements within it. So you can see how this is sort of a tree structure. You can see all the different, it's sort of broken down by HTML element. And so this is the tree that you can kind of walk around on if you're scripting, and you can have access to it and change things and move things around and that type of thing. Okay, but the data structure is really not important. The important thing is that if you get a bad script on your website, it can basically change the entire website. Okay, so it can rewrite anything that you see as a user. It can change and modify. Okay, or eavesdrop on. All right, so that's why this is important, because it's possible to get bad scripts, and so we want to understand how much damage they can do and you know, what are the conditions where they can act and not act. Okay, so when a resource comes in, the browser, as I said, it's going to tag it with an origin, okay? So what exactly is an origin? So an origin is going to be, where did it come from in terms of the domain? So this came from www.google.com, okay? It's going to tag it with the protocol that you received it over. So http://google.com will be different than https://google.com. Okay, so if the protocols change, then it's not considered the same origin. Okay, and then the port number, which we don't really use, basically everything that's HTTP goes over port 80, everything that's HTTPS goes over 443, and then there might be some weird scenarios where something's coming over another port, but yeah, anyways, that's the main thing. And then there's another 1/4 component, which is called an override flag, which I'll explain in a second. You don't have to worry about that for now. So an example would be HTTP test.pubspy.com 80, and then false for that flag. That don't worry about the last thing. Okay. All right. So then the policy is very simple. It's things are the same origin if they're exactly the same in all of those components. If there's any little difference, different protocol, different port. Even a different subdomain. So www.pubspy.com is different than test.pubspy.com. Okay, so it has to match exactly the subdomain. Then it's considered the same origin. Otherwise, it's considered a different origin. Now, could you change it if you wanted to? So let's say that I'm running some scripts and they're on test.pubspy.com, and I want the origin to be pulpspy.com instead because I want to interact with some other scripts that are maybe running on other subdomains. Are you allowed to sort of change it? And so the answer is yes, you are allowed to go up subdomains, okay? So you can go from test.pulpspy.com to pulpspy.com, okay? You can't go to sibling subdomains, and you can't go all the way up to .com, to the top level domain, okay? So the highest you could go is just the root domain for your website, okay? And then that's fine. So if you want all of your scripts to sort of have the same visibility, you might make them all run on the domain of the website instead of having them run on each subdomain. If you want to have sort of maximum, that's the most permissive, the most compatible way of doing it. It's the most typical. So most websites would work that way. Okay, so you set it, you just put set document.domain equals pubspy.com. And then this is where that flag comes in. So as soon as you override it, then it flips the flag and it says it's now true. Okay, and so that's part of the same origin itself. Okay, so it just means that if so if you see true at the end, it just means that it wasn't necessarily from test.pubspy.com. It was from either that domain or some subdomain, and they flipped the flag in order to be true. Okay. Now, like I said, to be the same origin, all 4 of those things have to match. Okay. So if the flag doesn't match, right, then it won't be a match either. And I'll give you an example of that in a second, but just in case you're curious. So technically this is only the same origin as, even if there were scripts that were from pubspy.com, but they didn't set the flag, then they would be considered a different origin. Okay.
JavaScript can deal with all the domains and subdomains.
Say it again. The
JavaScript from another domain can deal with the data of another subdomain or something.
So yes. So the resources will be tagged with an origin as well, and it's just really simple as long as the origins match. So the JavaScript comes from this origin, and the thing that you want to change, the image or whatever, it just has to come from that. It has to have the exact same tag on it. If the 2 tags are the same, then it's allowed to see it. But if they're different, then it's not. Yeah? Okay. Yeah. Yeah, so sorry. So the web designer does this themselves, okay? Yeah, so when you're coding up your HTML, you can stick like the set document.domain in the header of that HTML file, and then it will set it for it.
If you don't set it up yourself, by default it's also true.
So the default would be whatever domain it came from would be true. Yeah, so it would match exactly the domain that served it. Yeah. So yeah, and then the flag would be set to false if you don't do anything. Yeah. And then you can set it, so for HTML you can set it in the, like you kind of have to run a script in order to set it, kind of. But anyways, you can read about like the mechanics of how to do it, but yeah. Okay, so here's a list of 5 different URLs. Which of these are the same origin, if any?
First 2 of them.
Okay, first 3, sorry. Okay, any others? Okay, let's go one by one. So the first 2, are they the same? Okay, they're the same. The first and the third?
No, protocol different.
Okay, so the protocol is different. It's slightly, but notice it comes over HTTP as opposed to HTTPS. So that's enough to make the origin different. Otherwise, it's the same. Everything else about it is the same.
The port is also different.
The which?
The port is also different.
Yeah. 80 and 4. For HTTP, yeah, it's different.
Okay, yeah. Sorry, yeah. So one would go over port 80 and one would go over 443. Yeah. And then let's say the first and the last one.
Subdomain differs.
Yeah, so it's a different subdomain. So the same origin is very strict. It's not like cookies. There's no like wildcards or anything like that. So they're technically the same, different origin. Okay, so these 2 are the same. Everything else is different. It's either a different protocol or it's a different subdomain, or it's a super domain of it, which is also considered a different domain. Okay, now we'll think about this override. Yeah, just bring it. So let's say that Manon's website here, he sets document.domain to encs.concordia.ca. Is he allowed to do that? Is that a valid, are we allowed to change our origin from users.encs.concordia.ca to encs.concordia.ca?
Because
Okay.
the parents
Yeah, so we are allowed to do that. So we're allowed to go up. So it's a parent domain, so that's fine. And then we have another domain, which is encs.concordia.ca. Are those now the same domain that we did the set document on the first one? Are they the same origin, I should say? They're the same domain. Are they the same origin?
Flag is different.
Okay, so this is where the technicality comes in. So everything about it's the same. It's the same protocol. Therefore it's the same port, and it's the same exact same domain. But one we overrode, and the other one we didn't override. So that flag is different. Now let's say I do want these two to talk together. What do I have to do? Okay, so if I can set the flag on the second one, which is kind of stupid because I'm saying change the domain to the exact same domain that it already is, but this is what you have to do. Okay, this is what web developers do every day. So it's very common that they'll set the domain to be exactly the same as their actual domain. And the reason that they're doing that is so that that flag becomes true, and now they can interact with all the subdomains that also moved up as well. Okay? Yeah. Okay, so now let's talk about how you kind of blend websites together. So we saw it in the Moodle example. We saw that Moodle, you know, there's stuff from YouTube, and there's stuff from Moodle, and there's stuff from DoubleClick, whatever. There's a whole bunch of stuff, and it's all kind of running together. And so is all of that stuff isolated or not? Okay, and so the answer is it's going to depend on actually how you pull that resource into your website. Okay, so we'll go through. There's basically four major ways of kind of pulling content into a website, and then we'll consider what the rules are. Okay, so the first thing is, and these will I'll just give you the example of scripting because that's the most common with it. Okay. So let's say, imagine you have a website, and the website is at concordia.ca, okay? And in the HTML of concordia.ca, you want to put some JavaScript. You want some JavaScript to run. And so one way you can do it is you can actually just put it in the raw HTML yourself, okay? So you put a script tag, okay? And you can say that it's JavaScript, and then you can just write your JavaScript right there, okay? And then you close the script tag, and then you just go back to normal HTML, like, I don't know, paragraphs and bold font and that kind of stuff, okay? So is this script, what's the origin of this script, would you, if you had to guess? If you were the designer of a browser, what would you say the origin of this script is?
The upper branch of tree.
So not about trees, just like what's the, when I assign it, I'm going to assign it a port, a domain, and so what domain am I going to assign to this script?
Same as Concordia.
So sorry, did I say port? I mean, like, what domain? Concordia.ca, right? I mean, there's no other option. I mean, there's nothing else that you could conclude. Okay? Yeah. So that's the answer. Okay? It's not a trick question. So this is defined in an HTML file. The HTML file came from concordia.ca. It's sitting inside that HTML file. So if the whole HTML file is concordia.ca, then obviously the script that's inside of it will also be from concordia.ca. Okay, so that's fine. Okay, now another way you can pull a script in is you could have it in a separate file. Okay, so instead of writing it inline in the HTML, you could have it sitting in, say, a .js file. That .js file somewhere else, and then what you'll do is you'll still use a script tag, but you'll say, hey, go grab the script from this file, run it, and then that's it. Okay, so the syntax is, this is what it looks like. Okay, now in this case, the website you're on is concordia.ca. The JavaScript file that you're going and fetching is also concordia.ca. Okay, so what's the origin of the JavaScript going to be? Concordia.ca, right? Okay. Now, let's say that exact same scenario, you just move the file, right? So maybe I didn't write the file myself, someone else wrote it, they're hosting it, it's on GitHub, I wanna use it, it's a library or whatever. So now I have a script. I'm saying there's this lang.js file. I want to run it in my website, concordia.ca, but the file itself is on github.com. Okay? What's the origin of this going to be? So you have two options basically. Is it going to be Concordia or is it going to be GitHub? Okay? So let's just do a straw poll. How many people think concordia.ca? Okay, no one? How many people think github.com? A handful of people. How many people don't know? Too scared, too shy? Maybe half. Okay. All right. So this is what we call, first off, this is called a cross-site script. So you might have heard that terminology. You probably heard of a cross-site script attack, okay, because this is sort of dangerous the way it works. And so, okay, so a bunch of you said GitHub. So starting with you, you have the mental model that most developers had maybe 10 years ago, okay? Most developers would think the same thing, okay? But it turns out that the same origin is not that, it's actually concordia.ca, okay? And because this is not exactly intuitive, there was lots of problems, and that's why we had lots of cross-site scripting attacks and things like that, because it's not particularly intuitive, okay? So let's think about what's happening here. So what I'm doing is I'm going and I'm saying there's this JavaScript, you know, it's on github.com, but I want to run it in my website, which is concordia.ca, okay? So the mental model of what's happening here is it's as if your browser grabs that file, it copies and pastes that text into concordia.ca in the script element. So you have like a start script, end script. All it does is it grabs the file, it copies the content, it puts it between the two script tags, and we said if the code's between those two script tags, the origin is concordia.ca, right? Okay, so what it's doing is it's pulling in the code. It's coming from somewhere else, that is true, but it's still executing. It's just as if like you wrote the script yourself. Okay. Now let's think about the opposite. Let's think about if it were true that this would run with the same origin as GitHub.com. Okay. What does that mean? Well, that means that if I execute this script, it could go and change things on GitHub.com. Not like it couldn't literally change it on the server side, but what was being presented to the user, right? So, like for example, let's say that there was some content or something that you were pulling in from GitHub, and then you pulled in a script that happened to be hosted on GitHub, you wouldn't expect that could overwrite GitHub's content, right? Because it has nothing to do with GitHub itself. It's just GitHub's hosting a file, that's it, right? That script shouldn't have access to all of GitHub's resources that are being integrated in your website just because it's hosting a file, okay? So that's why it is the way it is. So if you think a little deeper about it, it makes sense that like this is the only way that it could be, but it is confusing the first time you see it, for sure, okay? So when you pull in a file from somewhere else, it's as if you're copy and pasting it into your context. So that code is running in the context of concordia.ca, not in the context of github.com. Okay, questions about this? Okay, now let's say that we actually wanted to have GitHub, we want to give GitHub a context on our website. Okay, so like a better example might be like, let's say Facebook. Like I want to have on my website like a little box and it has like a like button and it says that 10 of your friends have liked this article, and if you click it, it will like it. It will actually like it on Facebook itself, even though you didn't leave the website, and it will, you know, post it to your feed or whatever they call it. So could we do that functionality if we wanted to? Could we have Facebook have a little context that runs on our website? That would be useful, right? Okay, so the same origin policy is not letting us do that, because even if Facebook's like, here's a library that does it, as soon as we pull it in, right, then it's going to run in Concordia's context itself. So it's not going to work. You're not logged into Facebook, you're logged into concordia.ca. Okay, so that's where, let me just go through this. I think I said all of these things, but it's as if the script was copy and pasted into the script tags. Scripts with the same origins share the same execution environment. Scripts with the same origin can access the DOM. And this is just about sort of the dangers of scripting. So like if you just notice that if you do get a script that's running on a website, it can change the content of the website. It can ask for the cookies that are involved in this context. And then it can open connections, new connections. So it could post it somewhere back to the adversary. It could create a special text entry field, call it password, but it's actually a JavaScript thing that's running, and it's reading every character that you type into that field and like posting it back to like a bad server or whatever. So getting bad scripting on your website is dangerous. Okay, anyways, back to the question. So let's say we do want to have like a container and we're like, here, Facebook, you can fill in this part of our website. There is something for that called an iframe. Okay, so an iframe is a box. You usually actually specify as a box with like a size, but you can't see it. It's just invisible, unless if you want to put a border around it. But basically you say, okay, the iframe, the source for this iframe is going to be facebook.com/ad.html. Okay, so that's the file. It's going to get pulled in and it's going to run inside that box. So I make the box and I say, load that Facebook page inside that box. Okay, now what you have is basically a second website inside of your website. Okay, so as far as that little box is concerned, it's like an entire browser window. It's like a new browser window. And if that iframe is pointing at facebook.com, that box belongs to facebook.com. Okay, it's controlling everything that's inside of it. Even when I go and I fetch that HTML file, I'm going to send my Facebook cookies with it. So if I'm logged into Facebook, then I'm going to get that ad.html back, and Facebook will know it's me if I'm logged in. Okay, so it could personalize it. It could send me back a different ad because it knows who I am. Okay, or it could send me some information about who my friends are, or whatever Facebook wants to do. Okay, so they can put whatever they want in it. Okay. And then they can run scripts, okay? So let's say that Facebook launches a script inside of this box. What's the origin of that script? Is it Facebook script or is it Concordia script because all of this is happening on the Concordia website? Okay, so this is Facebook's in this case, okay? So this is sort of what we wanted to do here, or what everyone thought was happening that wasn't happening. The way to make that happen if you want it is to use an iframe. Okay, so you use an iframe, then you can run in the context of the iframe itself. So in this case, the origin that would be assigned to this would be facebook.com. Okay, so now the script that's running inside, okay, so let's say you have some images that are outside the iframe, you have some images that are inside the iframe, and then you have the script that's running inside the iframe. The script can access all the images and everything else that's running in the iframe. Okay, that whole iframe, the origin of it is facebook.com. Okay, so it can access all of its own resources, but it cannot reach out of the iframe and access anything that's on the Concordia side. Okay, because that's on a different origin. Okay, similarly, Concordia can draw a box and say, Facebook, you can fill this in. Okay, but Concordia with scripting can't reach inside of that iframe and pull anything that's being displayed out. Okay, so that's called, it's also from a different origin. Okay, so like let's say there's a like button inside of that, and Concordia really wants you to click on it. You're not clicking on it. It can't like through JavaScript like reach in and click it on your behalf. Okay, because it just can't see that information. Or even if you're looking at an article, it says 5 of your friends like this article, and it's from cbc.ca, CBC doesn't know that 5 of your friends liked it. Okay, that information was populated by Facebook. CBC can't see it if it's in an iframe, and so it has no access to it. Okay, so there's both the privacy concern and the integrity concern. So you can't access it in order to change it, and you can't access it in order to read it either. Okay, so in this case, they're completely isolated from each other. Yeah.
But Facebook would know that this iframe is hosted on this CBC site, so it's coming from here.
Yeah, okay, so the question is, when Facebook receives this, does it know that it was inside of an iframe? And so it's a question that I think the answer is yes, but like, it's not like the browser says, oh, hey, this is an iframe. Like it doesn't make it obviously clear, but I think by looking at refers and other things in the header, you could infer that information. So you wouldn't get it directly, but you could indirectly figure out that that's what's happening. Yeah. Okay, now let's say we do have a script that's on the Concordia side, and we have a script that's on the Facebook side, and they actually want to talk to each other, okay? Can they override this? Can they get around the iframe if they want to? And so the answer is yes, there is some functionality within JavaScript called post message. It does allow two scripts to talk that are from different origins, but both of them have to explicitly authorize the other origin. So Facebook would have to say, I want a post message with Concordia, and Concordia would have to say, I want a post message with Facebook. And if both sides agree to it, then you could pass information back and forth, okay? So there's no way for one party to do it to another party and the other party doesn't realize it. It has to be a two-way authorization. Then you're allowed to pass messages back and forth. Okay, so this obviously can lead to attacks. So the attack that's related to this is the cross-site scripting attack. And it basically says that if I can get my script running in the context of your website, then I can control at least what the user sees of your website, okay? So I can completely change the website. I can read the cookies off of it. I can create special fields like where you might type a password, but it's rigged up so that I could like log the keys that are being typed in and things like that, okay? So I can do bad things if I can get my code running in the context of your website, okay? Now, the thing I want to stress is I'm not changing your website itself. So there's a difference between like say your website has one image, a blue image, and I'm going to use cross-site scripting and I'm going to change it to red. I'm not changing it on your server, okay? It's not like I broke into your website and I replaced the blue image with the red image, okay? What's happening is when the user goes and they download your website, they first download the blue image, which is the true one, but then my script starts running and it says, oh no, go back and replace that with the red one. So then you go and you grab the red one instead, and then it's presented to the user, okay? Now, if the user was following along, right, they could see all of that happening. They could even disable my script to see what changes about the website. And like all of this is just happening, it's happening between the user's browser and the website itself, okay? So it's the presentation of the website to the user, okay? So I'm not like permanently changing the website itself, okay? So anyway, so just bear that in mind. Okay, so how do we do cross-site scripting? So there's lots of different ways of doing it. Basically, we want to sort of sidestep the restrictions of the same origin policy. And you'll take a networking course like 6130, I think, or 40, and they'll show you probably like 10 different variants of it. I don't really care. I'm going to show you 4 or 5. I don't really care about the technical details so much. I just want you to see like sort of why the policy allows it to happen, how it interacts with the policy. And I also want to show you like they can be very simple or very complex. Okay, so like there's a whole gamut. So the simplest thing that you can do is, let's say that someone has a popular JavaScript file and lots of people are using it because it's like a library that's most commonly used, okay? The simplest thing you can do is try and break into that file somehow, okay? So if it's being stored on GitHub, it could be guessing the password of the user that has that file, okay? And so you guess the user, you go in, you change the file, you put your malicious code in, and then you're done, okay? And so it sounds kind of silly, but this is the type of thing that happens. Domain names expire sometimes, right? So someone might have a popular JavaScript thing. They're not maintaining it, but still lots of websites use it and they haven't updated, or they continue to use it even though it's not being maintained. Then the domain expires, right? Then someone goes and they register the same domain because it's now expired, and now they drop in their malicious JavaScript. And then all the websites that were using it are now using the malicious version or whatever, okay? So this is the easiest way of doing it, but it's also like maybe one that we see the most often now, especially because most of the other types of ways of doing it are being locked down. Another thing is that let's say that the JavaScript just comes down unencrypted. So it comes down over HTTP instead of HTTPS. If you're in the middle, then you can change it. Okay? And so we noted this when we talked about HTTPS. We noted that, if you have scripting and it comes down over HTTP, it's very, very dangerous because it can basically rewrite the entire website. Okay? So now what browsers do is they actually block it. So as soon as you try and load something over HTTP that's active content, then it won't load it. It's that simple. It won't even try and fetch it from the server. Okay. So this attack doesn't work anymore, but anyway, for completeness, I included it. Okay. The classic kind of cross-site scripting is called persistent cross-site scripting. And basically it involves like going into like say a user profile, like say my Twitter profile, it says where's my location, and instead of writing Montreal, I write script in a tag. I put some JavaScript there, I close the script, okay? I press enter, it saves it, okay? So now that's in the website in that location field. Then let's say you come along and you look at my profile, all right? Then what happens is your browser hits that script tag and it doesn't strictly know that, it doesn't know that this is not HTML, right? Like it's supposed to be just text that's being stored, okay? But depending on how the website is set up, if they don't take any extra measures and they just sort of drop that text, directly into the HTML, then your browser will hit that script and say, oh, this is a script, I need to execute it, okay? And then it will go and it will execute that code. And then that code can do whatever you want it to do. So, so you need the browser to confuse data and code. It's called persistent because it's stored on my profile. So everyone that goes to my profile will see it. The first like kind of internet worms, they called them back then, were this type of attack. So there was like one on, I think it was MySpace, which was predecessor to like social media like Facebook and Twitter, and someone in their profile put a script. It would basically automatically make you follow them, and then it did some other stuff to it. And then it replicated. It made you change your profile to also include the code as well. And so basically, it spread kind of like a virus because 5 people would go to this person's profile, then their profile would change to include it. And then everyone that looked at their profile would change to include it. And then it was generating all this extra traffic, and it actually brought the whole website down. And I think like people freaked out about it, like the legal side of things. And I think the person like went to jail and stuff for doing it. But anyways, that was just a basic persistent cross-site scripting attack. Okay, these things aren't so common anymore. The reason is that most people don't just code raw HTML. They're going to use some sort of framework, and the framework people they know about this attack, and they've done everything they can to eliminate these types of things. Okay, so they'll sanitize user inputs. They won't let you put a bracket in period. So like a lot of things, if you just try and put a triangular bracket, it's not an allowed character. They'll try and mark it as text, so even if it were to show up in some HTML, it would be like it would be parsed out by the browser as code as text as opposed to code. So there's a bunch of tricks. You'll learn about them in a network security course, but this problem's been largely eliminated. Okay, another one. So then people had to get more creative. They're like, okay, what are some other ways we can get around it? All these cross-site scripting vulnerabilities have disappeared because also even if you're successful, people will notice it and then they'll fix it, right? So I'll show you 2 other that are kind of more elaborate ones. So this one is called reflective cross-site scripting. So the basic idea is this is going back to that RESTful architecture that we talked about. So if I go to Google and I search for CF Montreal, it's going to put that in the URL. The query equals CF Montreal. Okay. So what if I put in a script in the URL itself in that query field? Okay. Now, someone has to click on it. So I email it to you, right? And you open that email and you end up clicking on it somehow, okay? Then what's going to happen, it depends on the website, but what would be very common for a search engine is they think that that's the search query, okay? So they're going to go search for that search query. Okay, that's fine. It's some weird JavaScript, so there's probably no website that it matches anyway. Okay, so they're going to tell you, oh, there's no results for this particular query. But often what a website will do is it will repeat the query when it tells you that. So like if I search for CF Montreal and there was no results, it would say there are 0 results for CF Montreal. Okay, but here what would happen is it would say, oh, there's 0 results for script, blah, 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 and script. Okay, now that is embedded in the website, okay? And so now when my browser goes, or Alice's browser goes, and they parse this out, they're going to hit that for space, and then they see a script tag, and they think, okay, now I need to execute that script, okay? So it's another way of getting information. Again, it depends on how the website's set up, so it's not necessarily going to work on every website. And then from a web designer perspective, you have to protect against these as well. So every user supplied input, it doesn't have to be entered in a field that's on your website. If you have parameters in the URL and the user can control them, you have to think about how am I using those parameters in my website itself, and am I vulnerable to cross-site scripting through that mechanism of getting user input onto my website. Okay, so it's called reflected because you're reflecting it in from the URL. And yeah. Okay, and then basically like cross-site scripting was like very prevalent maybe 20 years ago. And then people spent a long time working on it. People came up with reflective, then everyone fixed it. And so there's been a lot of progress that's been made on protecting against it. But there still are like weird vulnerabilities that happen. So I picked one last example, and this is kind of the most elaborate one, but it just shows you, it's meant to demonstrate like that adversaries aren't going to stop. If it's not simple for them to do, they're not necessarily going to stop, right? As long as they can chain together enough things and make the attack happen, then it's okay. Okay, so this is called a self-inflicted cross-site scripting attack. And the way it works is this. We know that any user supplied data in a website needs to be sanitized, right? Otherwise, you're going to have trouble with cross-site scripting, okay? And so what these frameworks did is they really said, okay, every field, is there some chance that this field would be shown to the user? If the answer is yes, then they sanitized it like crazy, okay? But then there were some fields that were never shown to a different user, okay? So we sometimes call these administrative panels or admin panels. So you might go in and, for example, I might put my email in, and the server keeps it, and if I log in and look at my email, it will show my email to me, but it doesn't make it part of my public profile, okay? So if let's say that this field was vulnerable to cross-site scripting, I could stick a script there, right? But the only person I would attack is myself, right? I would go back to the website, I would see it, my browser would run the script and said I would attack myself. Okay, so it's self-infected. But I could not attack you with that, right? Because it's not displayed to you. If you logged in and went to the exact same website, it would show you your password, not my password, okay? So anyway, so people thought it wasn't that important to fix all these admin panels because like it was just shown to the users themselves, okay? So the idea of this attack was, well, is it actually secure? Okay, is it true that if this field is never shown to the public, it's only shown to this user, and it were vulnerable to cross-site scripting, is it actually true that I can't attack you with that? Okay, and so the answer is you can actually, but it's sort of elaborate, and you have to combine cross-site scripting and cross-site request forgery. If you put those two attacks together, then there is a sort of elaborate way to attack it. So this is how it works. I just thought it was sort of a fun attack. So the first thing I have to do is I do have to lure you to a bad website. Okay, so I'm not going to attack you by going to the actual website that's vulnerable with this cross-site scripting thing. So this could be like a real website like Facebook or something like that, but I'm going to lure you to my website, evil.com. So I don't know, I use phishing or something like that, and I somehow get you onto my website, okay? Then what I'll do is I'll iframe, like say Twitter, okay? And we know because of cross-site requests that this is an iframe, so this belongs to Twitter, okay? So the execution environment inside this iframe is Twitter, okay? And so when the user goes and asks Twitter to fill it in, they're going to send their cookies, and Twitter says, okay, that's fine, I know who you are, and then they'll send it back, and it will have, it can have your real profile information because it knows who you are, okay? Now, can evil.com reach in? Let's say my goal is to read that information, okay? So it says that 2 of my friends like my tweet. I'm evil.com, and I really want to know who were the friends that liked that tweet. Maybe they're private on Twitter or something like that, so I don't know who they are. So can I reach into that iframe and learn that information?
No.
I cannot, right? Why can't I?
The origin is not.
Okay, so the origins are different, same origin policy, so I can't, I'm stuck, right? There's nothing I can do, okay? So this is where I'm going to try and use cross-site scripting instead. All right, so the data is isolated because of the same origin policy, so I can't reach in from the outside and just read it out. Okay, so the next thing I could do is I could create a second iframe, and this iframe, I actually don't care about the content that gets loaded in it. I just want to use cross-site requests. And so we said that a lot of things you can do in the string, in the URL string itself. You can do actions with websites, and then websites don't have to keep state. Okay, so let's just imagine that the website Twitter was set up in such a way that you could sign out just by passing in a URL parameter. Okay, so I would iframe this. I would just hit twitter.com/profile sign out equals true or whatever, and then that would sign me out of Twitter. Okay, me being Alice in this case because she's on this website. Okay, so now she's signed out, but that first iframe still has that information. It already loaded. Okay, and I could put in delays or whatever I needed to make sure that I got that response first before I loaded the second iframe. Okay, so the data's still sitting there even though she's now logged in. If I tried to pull that data in again from the first iframe, it wouldn't work because now Alice is logged out, but it's still sitting there. Okay, then what I can do is I can log myself in as the adversary. So imagine I could do that. I could pass it's bad to do this, but I could pass my username and password in the URL itself. And then Twitter would say, okay, that's fine. I'm going to log you in. And now I have one of those self-inflicted user panels, right? So I have my location, I have my email set up. I'm the only one that can see it, right? But I have it set up with some cross-site scripting injected into it. So there's a script injected into my profile that only I can see. Okay, but now that iframe can see it. Okay, so that script is that's stored on my profile. It's now running in that third iframe. Okay, all right. So users' data is in the first iframe. Nothing's happening in the second iframe, and then the third iframe has the script that's running. It's a malicious script that I chose. Okay, I put it into my own profile. All right. Now the million-dollar question. Can that third iframe reach into the first iframe?
Yes.
Why?
The origin is the same.
Okay, so yes, they are the same origin, right? So everything on this website, there's only 2 origins. There's the stuff that's Facebook is controlling. There's the stuff that evil.com is controlling. Evil can't reach into the iframes. The iframes can't reach out back to evil, but the iframes can talk to each other because they're all the same origin. Okay, so the third iframe can reach into the first one. It can read all the data that's sitting there. It's sitting in the DOM. And then it can open up a new connection to evil.com, and it can just send it all back. All right, so it's the same origin. Script in the third iframe can read data in the first frame, and it can send it to an adversary-controlled server.
Sorry.
Yeah.
The second iframe is for logging out the user.
Yeah, exactly. So I thought it was more logical to split them into 3, but you wouldn't have to necessarily. Or you might use 4, like 1 to log in, 1 to navigate to the right website, or it might take a couple of these iframes, but yeah. The fact that there's 3 as opposed to 2 or 4 isn't the important point, is what I'm trying to say. Okay, so anyway, it just shows you like the people get really elaborate with these attacks because if they work, they work, right? It doesn't matter if you have to jump through a bunch of hoops in order to make it work. I mean, you can do a lot of damage with these things, and so anything that works is fair game for an attacker. Okay, and then we call it self-inflicted because you initially you put the script in a place where only you can see it. Okay, but then you manage to like actually infect Alice with your script, even though you could only see it. Okay, one other attack that's not exactly cross-site scripting. It doesn't really fit anywhere, so we put it at the end. But it's called clickjacking. But it's related. So the same origin policy is what makes this attack necessary. Okay, so this is a very simple, a really dead simple attack, but it's you'll understand why we need it. So let's say that we have this scenario. So I lure you to a website, evil.com. So I'm running my stuff on it, and I really want you to like my page on Facebook. So I create an iframe. I go get the information from Facebook. You're logged into Facebook. So when you request the information that goes into that iframe, it comes down with your actual data. And so if I click that like button, it will actually update my profile. And the fact that 91 of my friends like this article is real, right? Like there are 91, that's all in Facebook's domain. They all control. Okay, so blah, 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 that's fine. Okay, now I've said it a few times, but let's ask the question again. Can evil.com reach into the Facebook iframe and hit the like button? Can't do it, okay? It's not because you can't with JavaScript click on things. Okay, it's not the functionality of JavaScript. It's because it's isolated, right? So because of the same origin policy, I can't reach in and like it, even if it were possible to do with JavaScript, okay? So what do I do instead? Does anyone know clickjacking?
So make user click that.
Yeah, so I want to make the user click it. So how do I make the user click it?
Social engineering.
Yeah, maybe I could.
Set the iframe, so it wouldn't work on the phone, but set the iframe where the mouse is on the...
Okay, so you could try and move the iframe sort of under where the mouse is. So you probably wouldn't work, but yeah, it's an interesting idea. Speaking of that, can you move iframes around? Sure, you can put them anywhere you want, right? Can you move things on top of an iframe?
Like image or something like
Yeah, could you put an image over top of the iframe? It can't be inside the iframe, but could you say load an iframe at this location and load an image on top of it? Yeah? So that's exactly what happens. So you're like claim prize or whatever, and you take that image and you put it over the like button. Okay? Now, what happens when the user clicks on that? Is it like clicking on the image? Like say I clicked and drag, would it drag the image? Or would it click through the image? So let's say the user now really wants to click, right? They won, right? And so they're going to click on this thing. So first off, can I put, when I draw an iframe, is that like Facebook's territory, like all the layers up? It isn't. Okay, so I can actually put stuff over top.
first layer is for the Facebook, but
Exactly. So you can layer things on top of each other. So sometimes with mashups and things like that, people layer stuff on top. And then the last question is, when I click, if the image is at the top layer and the button's underneath, does the click go through the image or not? Well, the answer is you decide as a developer. Okay? So you can tell the website that I want a transparent click, and a transparent click says that when I click, it clicks through. Or I think by default, it wouldn't be transparent. Okay? But it's in the control of whoever set up the website. Okay? So the person who puts that claim prize button gets to decide whether you can click through it or not. Who put the claim prize there? Was it the adversary or was it Facebook? Adversary. So if the adversary wants it so that you can click through, is that possible? Absolutely. Okay? So this is clickjacking, basically. Now, there's a lot of restrictions now on transparent clicks, and a lot of like ad blockers and things like that. If you go to a website and you see a transparent click on an image, you basically say it's probably an attack, because there's not a lot of uses for it anyways. So there has been some stuff that was done, but there was a long time when these types of attacks happened all the time, and users didn't even realize it. Like, they would be like, oh, I think someone hacked into my Facebook because it's posting weird ads on my Facebook or a bunch of weird messages. But then, like, their password wasn't compromised. It happened once, but it never, like, it wasn't like repeated. It's not like someone changed their password. It happened sort of in isolation. And so that's like has all the hallmarks of clickjacking, right? So they went somewhere, they clicked on something, and it triggered a bunch of actions on Facebook that they didn't authorize. But it didn't actually, they didn't lose their account. They didn't lose their password. They didn't lose full control of their account. All they did was make some cross-site requests to it that they didn't realize they were making it because of it, okay? Now, websites will also protect against it now. They're already looking for cross-site request forgery anyway. This is kind of a cross-site request forgery, just with this extra element, so that if a user action is required in order, so Facebook wouldn't let you like it just by passing a URL. You would have to actually click on the button. That was their way of combating cross-site request forgery, and then this is the way to get around it. All right, so click is transparent and clicks through if you set it that way. And if the user is logged in, then if you're not logged in, this attack doesn't work. So you have to be logged in. But if you are logged in, then whatever you can do with a cross-site request, including user actions like having to click on things, then you can get the user to do it, and it will make real changes to the user's profile as a result. Okay, so the high-level lessons from both the cookie side of things and the same origin side of things. It's kind of the same as airports. It gets a little repetitive, but it's hard to get these policies right. A lot of the problems with cross-site scripting, same origin policy, was just the mental model of how it worked and how it actually worked were different, okay? And so now it's better because people have the right mental model, or at least there's experts in the field that know exactly how it works, and they'll try and make sure that there's tools and things like that to catch any vulnerabilities that are left. It's hard to analyze, so it's hard to say this is the methodology that you would use. The one methodology that I mentioned before, which actually I did some research back, I went back reading about the same origin policy and things like that, because I hadn't looked at it in a while. And so I noticed that there is this idea that I suggested for airports of formal verification. So with formal verification, what you do is you describe what's happening with logical statements, and then you ask a computer, is it possible, like, here's an attack that should never happen, is it actually possible or not? And then the computer will try every possible iteration within your model. There might be some computational limits on what it can do, so it might not be able to check everything. But it can find attacks. And so actually there were a bunch of people that modeled the same origin policy using these model checkers. There's a nice one called Alloy from MIT. And so they used it actually as the running example for it, and it looked really cool. So anyways, if you're interested in this stuff, maybe for a class project, or if you're in a thesis program or something like that, I recommend this Alloy tool and formal methods and model checking. They could solve these types of problems, or the kind of policy problems that we've seen before. The problem with them is, if you don't get the model right, then you're not going to find the attacks, right? Or maybe you have the same mental model as the developers, and so you're putting the wrong mental model into the actual model that you're checking, right? Then it won't find the attacks either, right? So that's the challenge of doing it. And then there's some computational limits too. You can't check every single case because it blows up exponentially. But these model checkers are actually pretty good about, even if you do a little bit of checking, you can often find all the important things, even with small depth checking. If you do find mistakes, or you, like, say people said, oh, the same origin policy, it's not right or wrong, but let's make it more like how developers think, right? You could make that change, but then it's going to break a bunch of websites that were, done the old-fashioned way, okay? So you have to think about backwards compatibility. Are you going to break old things if you just go changing things for things? So there is now there's a whole new policy language that's built into browsers called CSP, and it gives you a bunch of more fine-grained control over isolating things and not isolating things and stuff like that. And so this is added as a new layer. It's a new language, so all the old websites just won't refer to it at all. So it's a way to add new functionality. You're not really changing it, but you're giving more control over it in a backwards compatible way. But in general, with policies, once you set them, changing them can be hard. So sometimes you can lock yourself out of changing things. And sometimes you just break it. Right? So like, for example, when Google said we're not going to allow JavaScript served over HTTP, that broke a lot of websites. And they just said, too bad, right? We gave you a year warning. You didn't fix it in a year. Now your website's broken. Your users are emailing you saying that your website's broken. They don't know why it's broken. They just know that it's broken because it's not working. And then now the developers will probably fix it anyways to make it work again. Yeah, and then developers, they just want things to work. So, when it comes to same origin, they're always going to set their resources to the top level domain. And for cookies, they're going to use wildcards and make it the most open cookie possible and all that. And if you go read Stack Overflow, I have these cookies and they're not seeing each other. Or this JavaScript's not talking to it. It's just okay, set the override to the toppest level, open up post message between them, and turn it on for the whole domain. And all of this stuff, that's the type of advice that you get, okay? So developers, they don't always have a security mindset. Part of this is being mitigated by the use of frameworks, right? So now I just use WordPress, but then WordPress deals with this type of stuff, so I don't have to. But anyways. And then if you add these new overrides and all this type of stuff, it does add complexity as well. So it does get harder. If you were to do that formal analysis, now you'd have a much more complicated model to try and figure out and make sure that you're not introducing new vulnerabilities by doing it. So complexity is the enemy of security, we sometimes say. So it's something else just to keep in mind that you want to balance these things. Okay, so that's it for the browser policy stuff. Any last questions about it? Yeah.
In the beginning you said that normally it's not allowed to for the communication from the website from the iframe, but a special authentication is needed. So what is that special authentication?
Yeah. So it's called post message. Where was it? So I guess my head's sort of over it. But anyways, it's just a command or a function that you can run, and you can set it up. And both scripts will run it, and then then the browser will allow them to communicate. But you can only go over that channel. It doesn't let me access all the DOM. It doesn't let me access each other's DOMs, right? All it does actually is allow you to pass messages. So so you could take what's in the DOM, stuff it in a message, and then pass it to the other. But you have to manually pass stuff back and forth as well. Yeah. Whereas some of the security frameworks and things like that, they will let you, I think you can set it up so that you can access each other's DOMs directly. Yeah.
This might not be related, but what about cross-origin resource sharing headers? Do they fit into that same policy, or is it a separate policy?
I don't know. I think it has to do with cookies, right?
It's about, so the way I have to handle them is when a script wants to make a request, then the server accepting that request need to specify I accept requests from those domains.
I see.
Or is it the page sending it? One of the two need to say, oh,
that they accept the other side type of thing. Yeah, so it's maybe, I don't know the exact positioning of it relative to the same origin policy.
Because they use the same language, just different.
Right. Yeah, so if it has to do with origins, period, it's probably a problem that it's a roadblock that the same origin policy is putting in place that developers want to get around. But I don't know the details of it. Yeah. Other questions, comments? Okay, so the last thing I'll do is I'll just quickly reiterate that there is a class next Tuesday technically. It will not be in person. You just have to watch 2 YouTube videos. it's on the topic of ethics. Okay, so ethics, just very quickly, what are ethics? It's sort of like morals, or like basically what's good and bad. It's not strictly like what's legal and illegal, right? So sometimes we think of that. Ethics there could be stuff that's unethical, but it's still legal to do, okay? So laws tend to match ethics to some extent, but there's a bunch of, behaviors and things like that. And the main point of these two videos is that ethics is a consideration, even if you don't think it is. So, like, for example, the first talk, the person talks about like a candidate, they give a job talk, and I don't know, they work on databases and algorithms, and they're just making database algorithms more efficient, right? And so he asks the candidate, what are the ethical implications of what you do? And they're just like, there are none. Like, I just work on algorithms, that's it. And then his point was, well, if you make if you make it easier to collect lots and lots of data, then aren't you enabling mass surveillance and social media and Facebook having big data and things like that? You're at least making their job a little bit easier. I'm not saying what you're doing is wrong or you shouldn't do it, but you should at least think about the fact that you are indirectly contributing to big data and mass surveillance, right? And so that was the point of it, basically, just at the end. And so the point for this class too is ethics is something that we don't really teach in any of the other security courses, but it does play a role in what you do. Obviously, if you're going to, like, say you're a white hat hacker and you're going to try and find vulnerabilities in websites and things like that, we talk about ethics, there's ethical hacking and all of that type of stuff. But my idea with these two videos anyways is to get you to think even deeper than that and to think about the ethical implications of everything you do, basically, even if it's just math, it often has it. So examples we've seen from websites. So the first example is the one that I just said. So we said, like, in social engineering, let's say you're a white hat social engineer, someone hires you to test it. You don't want to go in and get people fired necessarily. You don't want to go in and start yelling and screaming at people or set up scenarios so that they fear for their life or things like that, okay? So these are things that would be considered unethical, even if they're legal to do. When we talked about user studies, we said you have to get ethical clearance. Okay, so that's the connection. And a lot of it has to do with, like, data collection. What are you pulling off of users? Who has access to it? How do you store it? Do you have their consent? Do they know what they're doing, what they're consenting to? Are you deceiving them? If you're deceiving them, it's not that you can't deceive them necessarily, but you have to tell them after that you did deceive them and what the true nature of the study was and things like that. We talked about HTTPS, so if you, sorry, there's a missing P there. If you don't have HTTPS, right, then you can monitor network data. With Tor, you could throw up an exit node. I think I mentioned that there were some academics and they were curious what goes over Tor. So they just put up an exit node. They captured all the data. People were very angry about it because it's not that they did this study so much, it was just that they didn't protect the data. So they said that, vulnerable users use Tor, and so whatever data you collected is actually very sensitive, and you're just carrying around on a USB stick, and you didn't even delete it after your study and things like that, and you shouldn't, or maybe you shouldn't even do that type of study, at all. Some people, like, I think in the second video, there's an example that's similar to it, but people might do censorship studies, so you might go to different countries, try and get users to run a plugin, and then you're going to open up connections to a bunch of different websites just to see whether it's censored in that country or not, okay? But still, you're getting a user to go look at sensitive material from within a country, right? And so that could have implications for them, right? If it is censored, if it's monitored, then the government's going to see that they're opening up those connections to those websites, right? And even though you're just doing a study, the user themselves don't even know that it's happening because it's just some instrument that's on the computer, right? There's an ethical implication to running that type of study. And then the SPOT program, which we said could have racial implications, and it was really about, it's supposed to be counterterrorism, but it was really about undocumented workers and things like that. Browsers, the cookies and things like that, we saw that, cookies aren't a neutral technology, right? Like they allow you to stay persistently logged into a website, but they also allow tracking. They allow ad personalization. If there's an election going on, I might target ads at you based on the election, based on the websites that you visited in the past, right? So I might try and manipulate your feelings and things like that. Okay. So anyway, these are some just quick examples to just introduce this idea of ethics. The main point to draw from it is that you might think HTTPS has nothing to do with ethics, okay? But usually if you look close enough at every little thing that you do, there is some ethical question that underlies it, okay? So that's the main point of these lectures, is just to open your mind to the fact that there are ethical implications, even if you're just working on math or just working on algorithms. Try and get you to think about it. They're very different. One's about crypto, and the other one is about network surveillance and things like that. And so they're two different perspectives. I'm not going to test you deeply on them or ask you like very detailed questions about it. I just want you to get the high level concept essentially from them. Okay? So you can watch those two. If you have any questions, you can email me, but hopefully they're pretty self-explanatory so that you don't have questions. Okay, is there any questions about this or anything about the course entirely? This is your last chance. All right, seeing none, then thank you. It's been fun. And if you have questions for me about your whatever projects or whatever, I'm here. All right.